Hi everyone, welcome to Unit 3, Lesson 4, Zero Power Rule of Exponents. Okay, so I have an example. This example is also in your lesson, but I wanted to go through it out loud with you. So first, let me block this one out. We don't need that one quite yet. So with exponents, right, we know that this pattern exists, right, where 5 to the first power equals 5, because the base tells you what you're multiplying, the exponent tells you how many of them to multiply together. So if I have 5 to the first power, that means I just have a 5, all right? So anything to the first power is just the base number itself. Moving on to the next one, 5 to the second power, also known as 5 squared. Well, again, the base, the bigger number, tells me what number is being multiplied together. The exponent tells me how many of them to multiply. So this would be 5 times 5, which is equal to 25. 5 to the third power is 5 times 5 times 5, which is equal to 125. So then what does that mean for if there's a 0, right? What happens there? Okay, and you might, maybe you've heard it, maybe you just know, you have it memorized, and that's awesome, right? That 5 to the 0 power is 1. Okay, or any number to the 0 power is 1. So we can prove that with the quotient rule that we worked with in the last lesson. So 5 to the 0 power. Well, let's say that we take 5 to the third power minus 3, right? So 5 to the 3 minus 3, well, 3 minus 3 is 0, right? I could work backwards, and again, this is like working backwards from what we learned in our last lesson. 5 to the third power, right? Because if the bases are the same, I can subtract my exponents. Well, 5 to the third power over 5 to the third power is equal to 125 over 125. Well, anything divided by itself, right, is equal to 1. So, since all of these are equal to each other, that means that these two are also equal to each other. Okay? So that's one way that we could prove that 5 to the 0 power, or any base to the 0 power, is equal to 1. Okay? So I hope that helps clarify it a little bit. I know there's a lot of mathing right now, but I hope it helps. So, let's go straight into our first example. 63 to the 0 power. Well, it's to the 0 power, so what does that mean about my answer? It's just equal to 1. Okay, there could be millions in there. If it's like, 5,797,365. If it's taken to the 0 power, it is equal to 1. Alright? So, kind of nice, right? Okay, number 2. This one is a little bit trickier, okay? Because we do need to discuss exponents and what they apply to. So right now, with this one, the exponent, the 0, is actually only attached to the 4. It is not attached to the negative sign. In order for it to be attached to that negative sign, there would have had to have been parentheses around it like that for it to apply. Okay? Another way we could think of this is, well, if there's a negative right here, we could say, well, that's like saying it's being multiplied by negative 1 times 4 to the 0 power, right? Anything times 1 is itself, but because it's a negative, negative 1 times 4 gives us negative 4. But that exponent is only attached to the 4, not the negative sign. Okay? So, with that, and then we can bring this down. Okay? So I know that's a little funky. That's a big stretch. All right, for things that we've learned so far. But this is technically still the same thing. Now, because of the order of operations, right, PEMDAS, we need to look for parentheses. There's not really parentheses right now. It's just like there's just the 4 in there, right? So there's nothing to apply. Next would come exponents. Well, now I can go ahead and I can say, okay, well, 4 to the 0 power is 1. So this is like saying negative 1 times 1 times 15. I didn't leave myself enough space, so I'm going to come over here. Well, negative 1 times 1 is just negative 1 times 15. Negative 1 times 15, well, it's a negative times a positive. So I know my answer is going to be negative, and 1 times 15 is 15. So your final answer on this one is actually negative 15. Okay? We could have gotten there a little quicker, but I wanted you to see why this was happening. So if the 0 is only attached to the 4, I can just bring the negative sign over here into my next setup, right? And then 4 to the 0 power is 1 times 15. And notice I'm at the exact same spot. I just didn't have to go through these other steps. Okay, and then once again, negative 1 times 15 is negative 15. Okay? All right, number 3. It says, which of the following is an equivalent expression to 7 over negative 5 and 3/10 to the 0 power plus 4 times 9 when applying the 0 power rule? Okay, I didn't write all of them out, but I just wanted to talk through it with you. So if we're applying the 0 power rule, that's this. It's like, let's simplify this. But notice with this one, and I didn't write it very well, I apologize for that. Notice this one right here, there are parentheses around the negative 5 and 3/10, which means that the 0 power is applied to the whole thing. So I could rewrite this expression as 7 over 1 plus 4 times 9. And I believe that's the answer in your quick check. Okay, but I wanted to talk through it. You could continue on, even we could solve this, right? We could say, okay, well, PEMDAS, if we're considering PEMDAS, right? Parentheses first, exponents next. We already did all of that. Next would come multiplication and division in the order that we see them. So here I have division first. Well, what's 7 divided by 1? 7. Plus, and then look, I have multiplication right here, so I got to do that next. 4 times 9 is 36. Giving me a final answer. Now I can add these together of 43. Now the problem, it doesn't take you that far, but I just wanted to see, I wanted you to see what that would look like. Okay? Okay, number 4. Which is equivalent? So I've got this expression up here. Here's another nice long one. Okay? Which is equivalent? So I'm going to go ahead and apply the 0 power rule and see, does it pop up with any of these? Okay? So let's see. According to PEMDAS, right, or according to the order of operations, first I have to take care of parentheses. So that means I have to do everything that's inside of these parentheses. Then would come exponents. Well, so I'm going to write my 1/2 again because I'm not doing anything with that yet. But inside my parentheses, well, gosh, let's see here. 9 minus 7 to the 0 power. Well, according to the order of operations, exponents come before subtraction. So I'm going to go ahead and do this one. 7 to the 0 power is 1, right? And then 9 minus. So 9 minus 1 plus, and then this parentheses over here, well, it's just got this exponent on it. I'm going to go ahead and apply it now because it's just negative 29 inside there, but I know it's the whole thing is being taken to the 0 power, so that's equal to 1. Okay? And if you notice right away, oh my gosh, look at that. That's answer A. It's identical to answer A. Okay? So that's going to be your answer on this one. Let's keep going just for good measure and for practice. If I were to continue, well again, I still have parentheses. I need to do 9 minus 1. So I would have 1/2 times 9 minus 1 is 8 plus 1. Well, these are being multiplied. What is half of 8? Of means multiply in math. Half of 8 is 4 plus 1. So if you were to continue going, your final answer would be 5. For this particular answer, you don't need to. You just need to know this. Okay, but I hope that helps. And as always, I'll see you in live lesson. And if you need extra support, let me know.